We can use Venn diagrams to find probabilities. Remember, a Venn diagram represents sets using closed regions. Anything inside a region is in the set. Anything outside the region is not in the set. We can then use probabilities and percentages to populate the regions of our Venn diagram. Now, before we do that, we have to be a little bit careful because the Venn diagram is a visual representation of the data. Correct labeling is critical. For example, if there are 38 elements of some set A, simply placing the number 38 inside A is misleading. As shown, this suggests there are 38 in A, but since where we've written the number is outside of B, then it suggests that these 38 are also not in B. And we might not want to assume that. To avoid confusion, it's best to write numbers in Venn diagrams only if they correspond to the exact region they're in. For example, suppose an analysis of a collection of accidents reveals that 27% of the accidents involve a young driver, 38% involve alcohol consumption, and 18% involved a young driver and alcohol consumption. If A are the accidents that involve alcohol and Y the accidents that involve young drivers, we can draw a representative Venn diagram as. Now, we can assume anything we want as long as we make it explicit. Since we're working with percentages, let's take a sample of 100 accidents. There are 27% of 100, or 27 accidents in Y, but there are two regions that make up the set Y, and we don't know how the 27 splits between the two regions. Likewise, there must be 38 accidents in A, but again, A has two regions, and we don't know how the 38 are split between them. We do know that 18%, 18, involve both Y and A, and so we know there are 18 in that intersection. Now, since there are a total of 38 in A, and we've accounted for 18, there are 20 in the remaining region. And since there are 27 total in Y, and we've accounted for 18, there are 9 in the remaining region. And since we're working with a total of 100, and we've accounted for 47, there must be 53 outside of all the regions. And now we can use our frequentist interpretation to find probabilities because we know our sample size. In this case, the probability that an accident involved a young driver and did not involve alcohol is 9/100ths. Or suppose we know that 34 students in a probability course include some who are math majors and some who are art majors. We also know that 5 students are both and 3 are neither, and there are twice as many art majors as math majors. If A represents the students who are art majors and M the students who are math majors, we can draw a representative Venn diagram as. Since 5 students are both, then the region where A and M intersect has 5 persons in it. And since 3 are neither, the region outside both sets has 3 persons in it. We don't know how many students are in the remaining regions, so we'll leave those unknown. But we do know there are 5 plus X art students, and 5 plus Y math students. And since there are twice as many art students as math students, we can set up an equation. But there are 34 students altogether, so if we add up all the students, we get 34. And now we have a system of equations which we can solve. And from this completed diagram, we can find the probability a student is not an art major, 10/34, and the probability a student is a math major, 12/34.